Okay, this is Algebra 2, Lesson 23. In this lesson, we're going to learn about another way to find a solution to two systems of equations. We learned there's two ways. We can do substitution and we can do elimination. Well, there's a third way. It's not the most efficient and it's not one I recommend, but it is an option if we have to do it. So for example, let's take this equation 3y minus 2x equals 6. And I'm doing example 23.1. Y plus x equals -1. Well, we can either use substitution or elimination, but first let's graph it. In order to graph it, we have to change these into the y-intercept form. And I'm just going to go ahead and use the book's already done it for us. And basically we're isolating y to one side, so you should know how to do that. I'm not going to go back and do that right now. In class, if you need some help, I'd be more glad to go over that in class. So now, can we graph this particular one? Yes, we can. We can get a graph. Right? We have the equation negative x minus 1. So the y-intercept is what? -1. And the slope is 1, -1. So up 1 over 1, up 1 over 1, down 1 over 1. Okay? That's my first equation. That's an easy one. The second one is y equals 2/3 x plus 2. So we're going to go to 2 up 2 over 3. Okay, do the opposite. Down 2 over 3. Okay, so the solution is where the two, remember, it's where the two equations cross. So there's our solution. So it's not exactly on a coordinate, but when we look at it, it's about -1.8 and 0.75 looks like the solution. Okay? We're just guesstimating. We're just taking a shot at estimating. That's why graphing is not necessarily the best way. So let's check that. Let's solve by using elimination. Okay? So I'm going to take this. Alright, I'm going to rewrite this to say 3y minus 2x equals 6. And I'm multiplying this one by 2 plus 2x minus 2. I'm going to solve. I have 5y equals 4. Divide by 5. So y equals 4/5. Okay? Then I'm going to put this in to find x. So I have, let me see here, yes, 4/5 plus x equals -1. So minus 4/5 minus 4/5 x equals, we add them, -1 and 4/5, or, yeah, -1 and 4/5, or -9/5, whichever one you want to call it. Okay, so -9/5 and 4/5 are my coordinates. If you divide these out, guess what? You get the same thing. They're equivalent. So that's all graphing is. That's just a third option. If you're in a hurry, you want to get a quick synopsis, say, okay, you want to kind of check to see if your answers are right. If I would have gotten a 2 for my x, I would have said, well, by using elimination, say I'm way off because I just graphed these. And if you graphed them correctly, the point of intersection is the solution to these two equations. But because they're not exact when we're graphing, it's really hard to, you're just estimating. So you have to put it back in the equation to see if it works, or use substitution or elimination for that. So let's look at example 23.2. Solve this system by graphing and then check your solution. So let's look at it. Our equation is y minus 2x equals 2 and y equals -3. Well, you have to know how to graph these. How do you graph a y equals -3? It's going to be a horizontal line. Okay? Then we have to change this one into slope-intercept form. which becomes y equals 2x plus 2. So we go to 2, and we're going to go down 2 and over 2, and then up 2 and over 2. So we kept going. It's going to intersect about right here. So I can keep going. Go 1, 2, 1. All right, 1, 2, 1. So this coordinate here is -4, -4. See that? No, it's not. Sorry. So yeah, so it's about right here. It appears to be -3. Well, I didn't do a very good job. So -2.5 and -3. Oh, I was way off here. So if you look at the book, there's a little more accurate. If you have graph paper, it's a little bit easier to see. So if you look at the book, it appears that this intersection right here, mine didn't go very well, is going to be at -2.5 and -3. Then they said, let's check our solution. Well, I'm going to use the substitution method. I have this. I simply replace y with what? -3. So -3 equals 2x plus 2. -2, -2. So -5 equals 2x. Divided by 2, x equals -5 halves. And then y put this in there, substitute for y. So x is negative, and we said y is -3. And that's the same thing as -2.5 and -3. So you can see doing graphing, we know how to graph, but because I don't have graph paper and my numbers are off, these are closer than these, they're not even, looks like the intersection point is at -4, -3. But if I would have done this on graph paper, the intersection point is actually right here. This equation goes down a lot steeper slope, and this should be moved over, and it would be -2.5, -3. So therefore we see graphing is a different way of finding a solution, but it's not a very efficient one or very accurate one because you're basically estimating. And how do you check it? You can put them back in, or you can do substitution or elimination. Okay, your code for this lesson is the number 511 on homework number 21. So write number 511 on homework 21. So all this lesson is graphing your equation, looking to see what the solution is. And I suggest you do this on graph paper so it'll be a little more accurate. And you're just estimating what x and y is at the point of intersection. And then you go back and do either substitution or elimination to solve for x and y, and to check your answers to see they're right. You practice problems, and we'll see you in class.